Bagging creates independent jurors and averages them. Boosting is different. It creates sequential jurors where each one focuses on the cases the previous one got wrong. AdaBoost, adaptive boosting, fit a simple classifier, a decision stump, just one split. Some points are misclassified. Increase the weights on the misclassified points and decrease the weights on the correct ones. Fit another stump on the reweighted data. It focuses on the hard cases. Repeat for B rounds. The final prediction is a weighted vote of all B stumps, where better performing stumps get higher weights. Gradient boosting generalizes this to any differentiable loss function. Instead of rewriting data, fit each new tree to the residuals, the errors of the current ensemble. The first tree predicts the mean. The residuals are what's left. The second tree predicts the residuals. Added to the first. New residuals are smaller. Each tree adds a correction. The learning rate, typically 0.01 to 0.3, controls how much each correction contributes. XGBoost, extreme gradient boosting, is the engineered version. It adds and regularization on the leaf weights to prevent overfitting. It uses histogram-based approximate split finding for speed. It handles missing values natively. XGBoost dominates machine learning competitions and has become the default for structured data prediction. The typical workflow: set a large number of trees, use early stopping on a validation set, and tune the learning rate and tree depth. Stacking takes a different approach. Combine diverse model types. Train a random forest and XGBoost model and SVEM and a logistic regression on the same data. Use their predictions as features for a meta-learner, a simple model like logistic regression that learns which BIS models to trust. The meta-learner is trained on cross-validated predictions to avoid overfitting. When to use which? Random forest, the reliable default. Few hyperparameters, robust to overfitting, interpretable feature importances. Use it when you need to understand which features matter. This AdaBoost, maximum predictive performance with more tuning effort. Use it when prediction accuracy is the primary goal. Stacking, when marginal improvement justifies the complexity. In biology, random forest for feature importance and AdaBoost for prediction is the most common combination. One tree is fragile, a forest is robust. Bagging averages independent opinions. Boosting corrects sequential mistakes. Stacking combines diverse experts. The jury delivers a reliable verdict even when individual jurors are imperfect. From biomarker discovery to clinical prediction, ensemble methods are the workhorses of modern computational biology.